Welcome to Practical Exercise Data Visualization Example 2. Today I'll show you how to use AI tools to turn raw data into clear visuals. If you often have data in your work or studies but find it hard to visualize, this presentation is for you. You'll learn how to use AI tools to make your data clear and effective. Let me explain what we'll do in this exercise. Our goal is to show how to turn raw data into clear visuals using AI tools without needing special skills. We'll use a real-world example to make it easy to understand. 1. Introduction. Choose an example for data visualization. 2. Data preparation. Obtain raw data from the article that needs visualization. 3. Results. Visualize the obtained data using AI tools. 4. Conclusion. Compare the new visualization to the original graph. 1. Introduction. Choose an example for data visualization. First, let's pick a good example for this exercise. Since I study at NYU School of Global Public Health, my academic focus is on population health. I explored available articles on this topic and found valuable research from the Department of Population Health at NYU Langone that provides critical insights into this field. An accomplished investigator, Dr. Joseph Palomar, who has received numerous NIH awards, and his team recently published an important article titled National and Regional Trends in Fentanyl Seizures in the United States, 2017-2023. This article analyzes regional trends in fentanyl seizures to examine potential shifts in illicit fentanyl availability using effective data visualization to illustrate these trends. Therefore, I chose this article for our data visualization exercise. While we use simple data to create a complex map in another practical exercise, in this exercise, we will learn how to visualize a standard data set and turn it into an informative visual representation. 2. Data preparation. Obtain raw data from the article that needs visualization. We examined the article National and Regional Trends in Fentanyl Seizures in the United States, 2017-2023. The article contains several charts and graphs, and we decided to focus on the graph showing the number of drug seizures in different parts of the country over time. This graph helps us understand how drug seizures have changed over the years. Additionally, it serves as a good example of turning a table with multiple columns into a visual representation. The investigator provided the raw data to create this graph. The data used for Figure 3 were obtained from the High Intensity Drug Trafficking Areas (HIDTA) program, which collects information on drug seizures made by participating law enforcement agencies. HIDTA data include the drug type, date, location, and form of the drug seized. Here is the dataset we obtained. We organized this data into an Excel spreadsheet to facilitate visualization. This dataset includes the number of fentanyl seizures over time across 4 regions: Northeast, Midwest, South, and West. The data covers the years from 2017 to 2023 and includes both observed and fitted values for each region. 3. Results. Visualize the obtained data using AI tools. Using Julius AI, I created a line graph to illustrate the overtime change in the number of seizures in the specified regions. To create the line graph, I provided detailed prompts to ensure accurate visualization. The graph should show the change in the number of seizures over time in 4 regions: Northeast, Midwest, South, and West. For data representation, the fitted values should be connected with lines, while the observed values should be displayed as dots without connecting lines. The line colors are specific: orange for the Northeast, green for the Midwest, purple for the South, and vivid pink for the West. The legend should include the names of the regions without mentioning fitted or observed. The y-axis should use a normal, linear scale with grid lines every 4,000 units. The background should be a light gray color, slightly lighter, and the grid lines should be white and placed behind the data points and lines. The graph should have an aspect ratio of 14:5, making it horizontally long. Lastly, ensure the lines and dots for the data values are clearly visible and not overlapped by the grid lines. Here is the data for the graph, attached. Please generate the line graph accordingly. Using this prompt, we successfully created an informative graph. 4. Conclusion. Compare the new visualization to the original graph. The final product was a detailed line graph showing the trends in fentanyl seizures across the 4 regions from 2017 to 2023. Comparing this graph to the original graph in the article demonstrates how effectively Julius AI can transform a standard dataset into an informative visual representation. To recap, our goal was to show how to turn raw data into clear visuals using AI tools without needing special skills. We used a real-world example to make it easier to understand AI tools. We chose an article related to population health research, obtained raw data from the article, and visualized it using AI tools. This exercise showed how effective AI is in improving data visualization for research. Thank you for watching.